All right, so you're doing it based on an equation, and that's what I'm going to go into now are sort of the equations that you'll see. All right, so the first main idea is you need at least 2 points to create a line. And this is just a random picture I drew of point A and point B. It's not the same setup as the thing I went over. So this is if A and B are just any 2 points. And I use x1, y1 to represent the x coordinate and y coordinate for point A, and then x2, y2 to represent the x and y coordinates for point B. And so that's what this is. It's just a picture of a line that's formed by connecting the 2 points A and B. And the main point is that you need, or main idea is that you need at least 2 points. In HOX, when we do the homework, you're going to be creating a line based on 2 points. All right, now the next main idea is forms of equations. Now, there's two main forms, the general form and the slope-intercept form. Now I put here, let me zoom out a little bit so you can see it all. So you'll see that x and y in blue, so those are in blue, and then the rest of the equations are in white. I underlined A, B, and C. I underlined lowercase m and lowercase b. Now those are numbers. All right, so A, a capital B, capital C are going to represent numbers. X and Y are going to stay as is in the equation. And then you have what's called the general form and then the slope-intercept form. We'll cover the slope-intercept form in extensive detail in section 10.3, so I'm not going to go into the details about that. Just know that if you're writing this down, maybe pause the video and write down these two equations. These are the general form, or the main forms, general form and slope-intercept form. And so the equations will have numbers, and then x and y are the two letters you'll see in the equations. It's just for any equation, you need to use a letter or something in place of that for any number. So that's why the common number or common letters they use are A, B, and C, and then the other one, M and lowercase b. All right, so write that down. You'll see a lot of them in 10.2 will, maybe not a lot of them, but a good number of them will have the general form. And then there'll be some of them that have the slope-intercept form. Now, real quick, before I move on to the next thing, for the slope-intercept form, the lowercase letter m represents what's called slope, and we'll learn about that in 10.3. And the lowercase letter b represents the y-intercept. We've already talked about the y-intercept in the previous section or previous video, and the y-intercept is a point that is on the y-axis. So b is where the line crosses, lowercase b is where the line crosses the y-axis. All right, so those are the two main forms, general form and slope-intercept form. Less common forms you might see is a form for a horizontal line. And the form for a horizontal line is y equals b. And b is supposed to be just some number, whereas y is actually in the equation. It'll stay as y in the equation. And so I drew a picture of an example of a horizontal line. In particular, it's y equals 4. And so the number 4 is like the lowercase b. And notice from the picture, the red line that goes through the y-axis at 4. All right, so horizontal line, y equals b. Another less common form is a vertical line, and it's x equals a, and a represents some number. And I drew a picture of an example, x equals -2. So in this case, -2 is what a is. And from the picture, It's a vertical line that crosses the x-axis at -2. I know in the past, sometimes students confuse the two forms. So just know that try not to mix these up. The horizontal line is always y equals b or y equals some number. The vertical line is always x equals a or x equals some number. And whatever that number is tells you where it crosses a particular axis. So like for a horizontal line, y equals b means that it's going to cross, since it's horizontal, it'll cross the y-axis of whatever b is. Vertical line, x equals a, it's going to cross the x-axis of whatever a is. All right, just a quick recap. I'll do an example, and then we'll do another video going over examples. So the main ideas, first main idea is you need at least 2 points to create the line. And in this picture, I use point A and point B, represented by coordinates x1, y1 for A, x2, y2 for B. Now the lines are going to follow an equation, and the two main forms for an equation of a line are the general form and slope-intercept form. So that's what you see here. The general form is ax plus by equal to c. A, b, and c are numbers, whereas x and y are actually going to be x and y in the equation. The slope-intercept form is y equals mx plus b, where m and b are numbers, and x and y are going to be as x and y in the equation. And 10.3 will cover the slope-intercept form in more detail. Less common forms, we have the horizontal line, y equals b, or y equals some number. It crosses the y-axis at whatever b is, and as a particular example, I did y equals 4. It's a horizontal line. That red line crosses the y-axis at 4. Vertical line is always x equals a or x equals some number, and in this example that I did x equals -2, and it crosses the x-axis at -2. So have those forms written down somewhere in your notes. We're going to be referring to those throughout the course. Now I'm going to do one example for this video, and then I'll continue with other videos doing more examples. So those are the concepts. So here's an example. So I'm going to graph this line, and it's 3x minus 2y equal to 6. Now, if you notice real quick that this has the general form. All right, so general form is ax plus by equal to c, and the different different components, a is 3, b is -2, and then c is 6. All right, so we know it's a line. So that helps when we draw the picture. So knowing that fact, knowing it's a line, I need 2 points to graph the line. So let me scroll down and rewrite the line. So it's 3x minus 2y equal to 6. And I said we need 2 points. To graph the line, and you plot the 2 points and connect them with the line. So how do we get the 2 points? All right, so what I recommend doing first, so this first method will work a lot of the time. So I would call it method 1. Method 1 is going to be using the x-intercept and y-intercept as the 2 points. All right, that's one of the methods, and it works, I would say, most of the time. The only time that it doesn't work is when, so I'm going to abbreviate, like in the previous video, I said x-intercept. Instead of writing the word intercept all the time, I'm going to abbreviate it as x-int. And instead of writing y-intercepts, I'm going to write that as y-int. All right, so using the x-intercept and y-intercept works most of the time. The only time it doesn't work is when the x-intercept and y-intercept are the same point. Okay, and when that happens, I would do method 2, which I'll talk about in a couple minutes. So when the x-intercept and y-intercept are the same point, this method 1, say, fails, and you would use what I'm calling method 2. All right, so maybe pause the video and write that down. I'm going to first work the problem out using this method, and then I'll talk about method 2. Now, this is a problem where it works. But so most of the time, using the x-intercept and y-intercept will work for the 2 points to plot the line or graph the line. Let me first talk about x-intercept and y-intercept before I do the problem. We've already talked about it before, so I'm going to say recall. For x-intercept, it's a point on the x-axis. And it has the form so it's going to be some number for x and 0 for y. So it always will have 0 for the y coordinate. So if I have a point, so let's say right here, I plot this point, that's an x-intercept, and it's at 3 on the x-axis. So we'd say the x-intercept is 3. All right, so x-intercept point on the x-axis has the form of some number for the x-coordinate and 0 for the y-coordinate. In this picture, I drew an x-intercept 3, which is the same thing as the point 3, 0. All right, now, this is just background information I'm going into first before I do the problem. Y-intercept is a point on the y-axis. It has the form 0 for the x-coordinate and then some number for the y-coordinate. So the x-coordinate is 0, x is 0. For the y-intercept. And let me draw a picture of one. All right, so let's say I have the following point. This is a y-intercept. And it crosses the y-axis, or sorry, touches the y-axis at 4. So it'd say y-intercept is 4, which as a point would be 0, 4. Okay, so now that we have the background information, give you a second to write this down. Now that we have the so yeah, pause the video, maybe write this down. Again, this is background information about x-intercept and y-intercept. And we're going to use this knowledge to actually do the problem. All right, so how do we do the problem? We're going to use the x-intercept and y-intercept as my 2 points. So 3x minus 2y equal to 6 is the problem. I'm going to use the x-intercept and y-intercept as my 2 points. That is method 1. So first, I'm going to find the x-intercept. And you can get that from an equation by knowing our knowledge for x-intercept. So the knowledge for x-intercept is that the x-intercept always has 0 for y. And so what you're going to do in the equation is let y equal to 0. So x-intercept, again, has the form of some number, comma, 0, but the point is that it has 0 for y. So I put 0 for y. So what you do is you let y equal to 0. All right, and that'll change this equation. It'll change it by turning it into 3x minus 2 times 0 equal to 6. And minus 2 times 0 is 0. And so this term goes away because that's 0. And you're left with 3x equal to 6. So the idea is to get x by itself. So what I need to do is get rid of the 3 in front of the x. You could divide by 3 because division is the opposite of multiplication. Whenever you have 3x, that's the same thing as 3 times x. All right, so to undo the 3 times x, you do divide by 3. And then these 3's divide out, and 6 divided by 3 is 2. All right, so I got x equal to 2. That tells me the x-intercept. And this is the x value for the x-intercept is 2. So that tells me the x-intercept is 2, 0. I'm going to box that. That's one of the points I'm going to use to plot the line. All right, so far I've done this for method 1. I found the x-intercept and I let y equal to 0 to do that because the x-intercept has 0 for its y coordinate. So plugging in 0 for y, change the equation 3x minus 2y equal to 6 into 3 minus 2 times 0 equal to 6. And the minus 2 times 0 is 0. So I cancel that out. It goes away, it's 0. And you're left with 3x equal to 6. And then I had to solve for x by dividing by 3. And 6 divided by 3 is 2. All right, the next thing I need to do is find the y-intercept. Now the y-intercept has the form of 0 for x and then some number for y. And so it's like the opposite of what we did in finding the x-intercept. Instead of letting y equal to 0, we're going to let x be 0. So 0 for x. And so you're going to let x equal to 0. I'll write the equation over again, which was 3x minus 2y equal to 6. All right, so I just got to plug 0 in for x, so it'd be 3 times 0 minus 2y equal to 6. And the 3 times 0 is 0, so that goes away, and you're left with minus 2y equal to 6. And then I have to get rid of the -2 that's in front of the y. And again, if you have a number next to the variable, it's multiplication. So it's like -2 times y. So you want to do the opposite of that. The opposite of multiplication is division. And so I'm going to divide by -2. And the -2 divided by -2, those cancel out and you just get y. 6 divided by -2 is -3. And that -3 is the y-intercept. So we got y equal to -3. That tells me the y-intercept. And it's 0 for x for the y-intercept, so it's 0, -3. Let me box that. All right, so that's the y-intercept. And here is the work. If you want to take the time to pause it, you can pause it. But essentially what you do is you let x be 0 for the y-intercept. So I have these 2 points I can plot and then connect them with the line. All right, so let me do that. And again, the original equation for the problem is 3x minus 2y equal to 6. So now we're actually going to graph it. I'm going to use point A, let's say in white, and I'm going to use that for the x-intercept 2, 0. Okay, this was the x-intercept. I'll use point B in green, and I'll use that for the y-intercept, which was 0, -3. Now, luckily for you, when you do the homework, the line part, Hawks fills in the line. You just got to plot the 2 points, and then the line gets automatically created. But I do recommend doing this first, doing everything by hand, getting an idea of what it should look like. All right, so I'm going to first plot point A. It's 2, 0, so that means it's at 2 on the x-axis. So let's start at the center. I go to the right 2 units, 1, 2, and that puts me here. That's point A. Now point B is -3 for the y-coordinate, so it's at -3 on the y-axis. Start at the center and I go down 3. And then I plot the point, and that's here. So that's point B. And then I connect them, and I'll have my line. And I put arrows at the end because the line's supposed to extend forever indefinitely. You can use different points for the line. There's an infinite amount of points that lie on the red line. It's just the 2 points that we used was the x-intercept and y-intercept. And so this is the answer. Okay, so that is using the x-intercept and y-intercept to plot the line, and that works like 95% of the time. There is a rare case where this method won't work in the sense that the x-intercept and y-intercept might be the same point, but you need 2 points to create the line. All right, so just for sake of demonstration, just to show you what the second method would be that I would do. So right now we already know the answer. based on, so this picture I drew is the line, and I created the line solely based on the x-intercept and y-intercept. The other method, and this worked, okay, so I wouldn't do it the other way that I'm about to do it. The other method is when the x-intercept and y-intercept are the same point, and then you have to find a second point. So method 2, really I only use this if the x-intercept and y-intercept are the same point. They are the same. That only happens when it's 0, 0. The origin 0, 0 is the x-intercept and y-intercept because they both are 0. Okay, so how do I do the second method? Now, what I'm going to do first is use either the x-intercept or y-intercept. So instead of not having to think about it, I'm just going to choose two values for x. Plug them in to get the y coordinates. So plug into equation to get the corresponding y values. And hopefully the y values are whole numbers. So hopefully the y values and the x values you pick, I would pick whole numbers. So hopefully the y values are whole numbers. If not, you're going to have to choose a different x value. If not, going to have to choose different x value. And that's because when we're plotting it in the software, it's going to be difficult to plot a point that has a fraction or decimal number as one of the coordinate values. All right, so if you want to pause it and write this down, and again, I only use this if the x-intercept and y-intercept are the same, but that only happens when the origin 0, 0 is the x and y-intercept. So what I'm going to do is choose two x values, choose two values for x, plug into the equation to get the corresponding y values. And hopefully the y values that you get are whole numbers. Now, if they're not whole numbers, you're going to have to choose a different value for x. All right, so let me work the problem out. And again, the original problem, the line that we drew was, so the equation was 3x minus 2y equal to 6. All right, so I'm going to pick two values for x. Generally, what I pick, I start with x equal to 0 and x equal to 1. And then see what happens, and hopefully the y values are whole numbers. Now, luckily, we've already done the case when x is 0 because that is the actual y-intercept, but let's say you don't know what a y-intercept is, then you could just pick a value for x. So let's say we plug 0 in, and then I'll get 3 times 0 minus 2y equal to 6. And so we did this before in the first method, because this gave us the y-intercept, because this, so 3 times 0 is 0, that goes away. You're left with negative 2y equal to 6. And then we divided by negative 2. And that gave us y equal to negative 3. So when x is 0, we got y equal to negative 3. That means the point is 0, comma, negative 3. All right, so that works because we have whole numbers for the coordinates. Now I'm going to try plugging in 1. All right, so let's see what happens when I plug in 1. And again, we're always plugging it into this as the original equation, 3x minus 2y equal to 6. So plugging in 1 will be 3 times 1 minus 2y equal to 6. And then you'll have 3 times 1 is 3. I want y by itself, so I need to first get rid of the 3. And I would subtract 3 from both sides. Those cancel out. I get negative 2y equal to 6 minus 3 is 3. And then I need to get rid of the negative 2, so I divide by negative 2. And you get y equal to negative 3 halves, or negative 1.5. But that's not a whole number. That's not a whole number, so I wouldn't use this point to plot the line. Okay, so I would disregard x equal to 1 and choose a different x value. So here's the work. When you plug in 1 for x, you get y equal to negative 3 halves, but the y coordinate's negative 3 halves, which is negative 1.5 as a decimal number. And it's easier to use whole numbers to graph the line, especially when you're using the Hawk software. Because you'd have to guess where negative 1.5 is for the y coordinate based on the software. So I would probably discard this. And then try a different value for x. You see that this process is a little tedious because you get something like this where it's not a whole number. So try a different value for x. Now it worked for 0, 0 comma negative 3. It's just when it plugged in 1, we got negative 3 halves, not a whole number. So I'm going to ignore x equal to 1, and let's try something else. All right, well, maybe let's try x equal to 2 and see what happens. Now the equation is 3x minus 2y equal to 6. Now I'm trying to plug in 2. So I get 3 times 2 minus 2y equal to 6. 3 times 2 is 6. I need negative 2y by itself, so I would subtract 6. I get negative 2y, and the 6's cancel out. And then notice on the right-hand side, you're also 6's cancel out. You get 0. Negative 2y equal to 0. And then I divide by negative 2. And 0 divided by any number is 0. except for 0 divided by 0. So this gave us y equal to 0. That means the point. We plugged in 2 and we got y equal to 0, so it's 2 comma 0. Right, and just an aside, anytime you do 0 divided by any number, it's equal to 0, except you can't divide by 0. 0 divided by 0 is undefined. So 0 divided by -2 was 0. Right, so if you want to pause that and write that down. Now here is the work. When I plugged in 2. So 3 times 2 is 6. So we subtract 6 from both sides. And then you get -2y equal to 0. And then I have to divide by -2 to get rid of the -2. So then 0 divided by -2 is equal to 0. So the y value I get is 0. That corresponds with x equal to 2. And so I have these 2 points, 2 comma 0 and 0 comma -3. And then you plot the line. Now, it just so happens that it was my choice. I just picked x equal to 2. I could have picked a different x value. Didn't put much thought into it besides that. All right, 1 didn't work, so let's try the next value after 1, 2. And I got a whole number for the answer for y, it was 0. All right, and it just so happens that these 2 points are the intercepts. Based on my selection, so the selection of x equal to 0, that gives me the y-intercept. And the selection of x equal to 2, it turns out that that gives me 2, which comma 0, which is the x-intercept. It just so happens we got the same 2 points in method 1. And then you would plot it. You know, we have 0 comma -3, 2 comma 0, plot the 2 points. Here's 2 comma 0. Here's 0 comma -3, and then I form the line. And it just so happened that the choice I picked for x such that I got the same 2 intercept values, same values for the 2 points from method 1. All right, so I just wanted to show that this is a second method you could try, and I would only do this if the x-intercept and y-intercept are the same, but it's not in this case. The x-intercept and y-intercept are 2 different points. But you would do it in this fashion. You would choose 2 values for x, plug the equation and plug them into the equation to get the y values. Hopefully the y values are whole numbers, and if not, you have to choose a different x value. The first value I chose, I normally go with x and 0, or x equal to 0 and x equal to 1. Now, when I plugged in 0, I got a nice whole number for y. I got -3. All right, so 0 comma -3 is a point I can use to plot the line. Then I tried 1, but that didn't work out nice because I got y equal to -3/2, which is a decimal number, -1.5. So it's not a whole number. And so I discard 1, and then I choose a different x value. And then I just chose x equal to 2. I didn't put much thought into deciding that. Besides, it's just some value after 1. I could have picked a negative value for x. It doesn't matter as long as the output, so we call it output for y and x is the input. So as long as the output's a whole number or the y value is a whole number. And it worked out for x equal to 2 because I got y equal to 0, which is a whole number. And it's just a coincidence that because of these 2 choices, the values that worked for x, namely x is 0 and x equal to 2, it gave us the same 2 points. 0, -3 is the y-intercept, and 2, 0 is the x-intercept. Those are the same 2 points that we found earlier with method 1. And so we plotted them, we have that line. All right, so that's a summary of method 2. Here's method 1. Method 1 was just using the x-intercept and y-intercept. X-intercept, you let y equal to 0. We got x equal to 2. Y-intercept, you let x be 0, and we got y equal to -3. Obviously, I would do method 1. It is the quickest method. All right, so hopefully that makes sense. The following videos will be going through examples after examples. I'm going to usually go with always doing the x-intercept, y-intercept route, unless I find a case where the x-intercept and y-intercept are the same. All right, so that's it for this video. I'll follow up with other videos.